Let me just tell you quickly about Dr. Jacobs. Many of you know his many accomplishments, but I'm going to go through these so you can hear them all in one, hopefully at least many of them in one breath, the highlights. Dr. Jacobs received his BS in electrical engineering from Cornell University in 1956 and his SM and Doctor of Science degrees in electrical engineering and computer science from MIT in 1957 and 59. He was a faculty member in electrical engineering at MIT from 1959 to 1966 and professor of computer science and engineering at UC San Diego from 66 to 72. While at MIT, he co-authored Principles of Communication Engineering, the first textbook on digital communications and information theory. In 1968, Jacobs co-founded Linkabit Corporation, moving from consulting services to become a major supplier of digital communication equipment for government and industry. He sold Linkabit to MACOM in 1980, remaining as board member and executive vice president until 85, when he and 6 others from Linkabit co-founded Qualcomm. Serving as chairman and CEO until retiring in 2005, he led Qualcomm in pioneering CDMA technology to provide highly efficient voice and mobile wideband internet access for cellular networks and becoming the underlying technology for all third-generation cellular networks serving billions of subscribers. Qualcomm is now the largest supplier of integrated circuits for mobile devices. Jacobs is a member and past chairman of the National Academy of Engineering. He is a fellow of the IEEE, American Association of the Advancement of Science, and the Computer History Museum, a member of the Academy of Arts and Science and the American Philosophical Society, and an inductee into the National Inventors Hall of Fame. From 2006 to 16, he was chairman of the Salk Institute for Biological Sciences and serves on International Advisory Board for the Technion Israel Institute of Technology, and for 17 years served as an advisory board of the School of Economics and Management at Tsinghua University in Beijing. There are just tons and tons of honors here. I'm going to again just highlight quickly because I don't want to use up all the time right now, but let me just say he's the recipient of 10 honorary doctorates. I'm going to finish off here by saying he and his wife Joan Jacobs have been cited by Business Week among the 50 most generous philanthropists in the United States. And I want to also recognize Joan Jacobs, who is here in the audience. Because of their generous philanthropy, we are all here today, supported by the Jacobs Institute for Innovation in Education, an institute with the mission to power K-20 innovation for all learners. Our moderator today for today's chat is Jabez Lebret, an entrepreneur and recent co-founder of Sisu Academy, an all-girls tuition-free boarding high school for underserved girls in San Diego, with an emphasis on edtech entrepreneurship. Jabez has hosted several podcasts, is a former journalist for NBC, and currently writes for the Forbes Education Desk. Please join me in welcoming Dr. Irwin Jacobs.
I think the biggest lesson from today is to have them read my bio first.
When he has more breath to expand it. There you go.
Well, it's a pleasure and an honor. Thank you for coming today, and I really appreciate all of you joining us. I want to start off the conversation going way back to kind of your childhood and thinking about what motivates us and creates some of our work ethic. And I understand that your parents owned a restaurant, and I'm wondering, did you work in the restaurant growing up? I'm guessing you did, and did that have an impact on how you developed into the work ethic that you have today?
Well, I grew up in New Bedford, Massachusetts, and part of that was during the end of the Depression and then World War II, so those all had an impact. And I started working probably when I was about 9 years old. Actually, my grandfather had a butcher shop, which was very helpful during the war. And so I would work there. I learned how do you wrap meat, etc. How do you take care of customers properly? And I had all kinds of jobs. I was a lumberjack for a time period, cutting down trees. I worked on haberdashery, etc. So a lot of interesting things to do. The New Bedford school system wasn't quite like El Cajon Valley. And talking about science, the grade school was K through 8. In 8th grade, I had both my first male teacher and my first science teacher. And he explained very early in the class that the only reason he was teaching science was he had the lowest priority in the school at that point. So it wasn't given the right priority. My folks did buy a restaurant while I was a senior in high school. And I did work there. I learned to sort beer bottles, among other things, wash dishes, pots, pans, and do a little bit of cooking. In any case, when I went to see my high school counselor decide about which universities to apply for, no one in the family really had much of a background. And he said, there is no future in science nor engineering, when he learned that was my interest.
He was barely right, almost.
Almost. So the question then was, well, what else? And when he learned my folks had a restaurant, he said, well, you have to go to Cornell University to the hotel school. So I did go to Cornell to start out in the hotel school, spent a year and a half there, and that's where Joan and I met. So that had a lot of useful aspects. And actually, from a course point of view, I did have a year of accounting and a half year of business law, which much more recently has turned out to be very useful. I also had a roommate who was an engineer, and peer pressure, as you all know, is very important. He kept telling me you couldn't possibly get those grades if you were in engineering. And so just at the early part of the Christmas holiday, went back to New Bedford, visited actually with my chemistry teacher, my math teacher from high school, and decided time to go back and try to make a change. That was interesting. Luckily, Cornell has a relatively open mind about these things. But when I told him I wanted to transfer from hotel to engineering, he kept trying to correct me because everybody transferred from engineering to hotel. So it took a while to get that point across properly. Luckily, I did transfer over to engineering.
Were your parents supportive of this move?
My parents were fully supportive.
That's great.
Mm-hmm. And so was my girlfriend at the time, so that was okay.
And so you, after studying engineering, you went on, you were working at the MIT Lincoln Labs, and you got this crazy call to come help join a school, a brand new school out here. And I believe we have Bad Weather and Joan to thank for possibly you ending up in San Diego. Maybe you could share with us a little bit about the story of how you actually came from New England over here.
Right, well, people had always told us how wonderful California was, so we actually took a year's leave of absence in the 64-65 academic year from MIT to be on a fellowship at Jet Propulsion Laboratory. And so we bought an old used camper. We had 3 children at the time. We camped cross country, although Joan always points out we also stopped in motels to get showers. And spent 9 months, found San Diego, lovely city, Santa Barbara, Berkeley area. And so we said, this is going to be a great place to retire at some point. Went back, just after getting back, had a call from a former professor at Cornell saying he's coming out to a brand new school in San Diego. Would I be interested in joining the faculty, help start engineering? Well, it sounded intriguing, but family, friends, everybody's on the East Coast, so we turned it down. 2 days later, we were kind of unhappy during those 2 days with the decision, right, wrong. 2 days later, heavy rainstorm, came back from MIT soaking wet, stepped in the door. Joan said, listen to this, we've been looking for a home around Boston. Described a lovely sounding contemporary home. I said, great, let's go see it tomorrow. She said, there's only one trouble, it's in La Jolla. That was the straw that broke the camel's back or whatever. In any case, we called up and said, if it's still open, we're coming. Got back in the van that next summer, and out we came
That's fantastic. And I understand you're celebrating 65 years
in September.
together in September. So congratulations. That's that is an amazing accomplishment. So that's pretty incredible. So you start your first company, Linkabit, and there was a moment where mentioned in your bio where in the 1985 or so, the six of you decided to peel off to start Qualcomm. And at the time, you, if I understand correct, you needed to focus on, you needed money. So you got your first customers were in trucking, satellite tracking on the trucking
Yep.
side. But you had this crazy idea of utilizing this technology that you'd studied a lot called CDMA, as opposed to what was the more commonly used, or at least the competitive TDMA when it comes to cellular. And I think the first phone you built was about the size of this table.
Somebody else built that. To demonstrate the technology, no, it
Yeah.
was a little larger. We needed a van to drive.
Oh, it was
around.
larger than the. So my question is, because we have a lot of innovators in the room or people that are interested in helping create change, there's often a moment where you're deciding to go all in on a new idea that hasn't been done yet. How risky was that at the time? How did you make that decision? How did you know you were heading down the right path?
Well, let me step back a little bit. The reason Linkabit got started, I was teaching at UCSD, very happy about that. But had lots of requests for consulting because of the textbook having come out, and digital communications was brand new at the time. You usually consult a day a week at most. And I mentioned that to a couple of faculty friends at UCLA, and they said, let's start a company and share consulting. So that's how Linkabit started. We had no business plans, or those of you who might be entrepreneurial in the audience, you usually think of a product, get a business plan, et cetera. We had none. But we had a lot of ideas. Those began to grow. The company grew, did sell it after developing many very good products. And then retired for 3 months, decided that wasn't much fun, and started Qualcomm. And again, when we started Qualcomm, didn't have any product in mind, didn't have a business plan. We knew that probably digital technology would be of interest and wireless would be of interest, and that some ideas would pop up. And so
This sounds incredibly scary.
Given we had 4 sons and a family to support, et cetera, et cetera. In fact, one of the favorite family stories is a couple of friends of my parents heard that I was left my job and started worrying about it, and then they reassured her that Joan had a good job at the time, so it was okay. Any case, yes, taking on risk is always energizing, but there are always lots of possibilities. So in the case of Qualcomm, did not have any product in mind, but within the first few weeks, came up with the idea that perhaps CDMA technology might be of use. Actually, it was a consulting job we had with used aircraft, and unfortunately, the consulting ended because they found out that the FCC was going to take 3 years to make a decision about their request for a license for a mobile satellite system. We didn't have the funding at that point. There was another company that had given us a contract to develop a two-way data communication system for the trucking industry. Now, this was before cell phones that, of course, give you all the data connectivity you want now, but would provide data across the whole continent and also position location. So we basically, this was again before GPS, invented our own GPS system.
I like that you casually dropped that. Oh, we just invented our own GPS system to help the trucking industry. And then you use that to kind of ride yourself into the next move?
It's actually one other interesting point there. So we went out marketing and By the way, engineers also, if you know the product, it's also good to be the salesperson and marketer. And you learn things. You always learn things. One of the things I learned there is we provide them with communications. That's not enough. We have to get into their software, their logistics management system, et cetera, and help them make use of this data. And so we had some more development to do. But in any case, that ended up being successful. And your question?
Well, it sounds like you just jumped right into CDMA because you guys just figured it out. And
Yeah.
you decided, why not?
So we had the money at that point, some funds coming in, and we returned our attention to CDMA, which was a technology possibly for the cellular industry. Now, the cellular industry originally did use big phones because it was what's called first generation. They were essentially FM radios. But the industry was growing. Everybody realized they had to go from analog to digital, and what technology should they use? Industry had a big battle. One CDMA was considered around the world, but thrown out too many problems, probably wouldn't be beneficial, too complicated, so everybody else left it, luckily. And there was a battle between, again, initials, acronyms, FDMA, Frequency Division, and Time Division, TDMA. And at Linkabit, we had developed the first commercial TDMA phone, and it turned out with supporters of that and others, TDMA won a balloting between all the cellular companies in the States. And so TDMA was selected in January of '89. We finally felt confident enough about CDMA 2 or 3 months later after this battle had gone on. And so, of course, when we went out to tell people about CDMA, everybody scoffed at us. But luckily, we were able to get a meeting set up in Chicago by the cellular industry. About this number of people, actually, but people with lots of background. And I made a slide presentation, and I thought probably a 50% chance somebody would raise their hands and say, you forgot about this, this is the problem. Nobody luckily did, but nobody believed slides anyway, so then we had to build a demonstration system, and that's the one that took a van to drive the mobile around. Invited people back again to see that, managed to convince enough of them that indeed we had solved the problems. We were able to then get some licenses from manufacturers who would take a chance because the operators realized that if CDMA did work, they could get many more subscribers in the amount of radio spectrum they had, so economically would benefit them. And so they agreed that they would urge the manufacturer to sign licenses with us. The license would give us an upfront payment. And should this ever become commercial, which most people doubted, a small royalty per phone.
That worked out.
That worked out. So we were able to develop the chips to make the phones. Then we went back, managed to convince the industry to go for a second standard with CDMA. That all got finished in the summer of '93. In the fall of '95, the first cellular CDMA network went public in Hong Kong. Now, people always say, why Hong Kong? Well, nobody had office. It was still a poor city, state, or whatever at the time. And offices were in the streets, and they used cell phones to communicate. And so the spectrum was overloaded. We promised more efficient use of spectrum, and we were able to get that started. So then they needed phones in Hong Kong. Nobody else was manufacturing phones. We had taken the prototypes we developed and the chips and made the first phones. And so for a number of months, probably into a year or two, we were shipping phones made in San Diego to Hong Kong.
I really hope you had a sticker on there, made in San Diego.
Well, went even further. The next two networks to come up with were in South Korea. And you might say, how do you convince South Korea to go with this new technology? every country, by the way, I did a lot of international traveling, every country was different. In South Korea, the argument was, you're trying to develop commercial electronics manufacturing. You're always behind Japan. Japan has selected CDMA, thinking that was the direction US would go. And so if CDMA works out and you adopt it, then you could be ahead of Japan. And it took a fight. Samsung was against it at the time. LG was okay. The government did adopt it. And so they went with CDMA. At the time, neither Samsung nor LG had essentially any cellular business. Now, of course, Samsung is the largest one at this point. But in any case, they didn't make the phones initially. So again, we shipped phones from San Diego to South Korea. And finally, then, of course, in the US. So it began to really sprout.
That's awesome. Something that you do in your approach that I think is really important is that you say that you take engineering, which is your background and your knowledge base, and then you apply it not to small incremental changes, but significant large things. And we're at an education conference right now, and you have been very active in education over the years. I'm curious what your thoughts are as to what big, significant things should we be thinking about as educators for the K-20 space?
Well, first of all, that the world's going to continue to change very rapidly. And so one thing that all the kids K through 16 and beyond have to get is a very good education. And that has to span areas where they have interesting work and applications, but also some good basic theory, because the basics never go away. For example, people ignored statistics for a long period of time. Now with big data, it's something very important to understand that as a basis for deep learning, et cetera. And so all these things change. With education, of course, as Silicon Valley has gone into, Cone Valley, I don't think you used the L on that, okay? I'm terrible with keeping names straight. But in any case, that getting technology into the classroom is very helpful. It's very helpful for the kids to have that available 24/7. So not just in the classroom, have to take it home. That means you have to have connectivity at home as well, and be able to have peer-to-peer communication, not just, again, in the classroom, but also at home. I think that's a key part of it. But then where's technology going? And I think you hear a lot these days about virtual reality, augmented reality. Indeed, that's coming along with the wireless technology, and fairly be a set of glasses you can wear. For some of us who are older, that's going to be very helpful, because one of the things those glasses will do for you is, as you walk up to somebody and can't quite remember the name of the last time you were together, it'll whisper in your ear. So lots of great advantages. But on the education side, I think it's going to allow you to have experiences while in place that expose you to other countries, other times of in the world, all kinds of issues with why did this invention make a difference. I think there's just room for all kinds of ingenuity coming up to make use of this new technology.
How do you think we are doing in our current education system at tackling or grabbing onto that ingenuity or that opportunity to be curious?
In most school
grow?
districts, unfortunately, much too slowly. And so I think, again, these kind of conferences and success stories, getting those out there, being able to communication is always important. Be able to get that communication out, let others recognize it, and then provide the proper training program. Particularly, one has to start with the teachers, maybe with the principals, maybe with the superintendent, teachers, and principals and teachers, but get this information out there, get people excited, and then get that excitement down to the students. But again, there's so much happening. I think this world of work idea is a great one. One of the things when they started Think-A-Bit, which you can tell is a little bit like Link-A-Bit, but not quite, started Think-A-Bit, Ed was very instrumental in doing that. And I went to visit, and the 5th and 6th graders were all there. And the first thing they did was bring in some employees in different, I mean, Qualcomm's obviously a high-tech company, so a lot of engineers, but just about every other discipline works there as well. And so exposing the students to all those different disciplines, getting them motivated. The reason 5th and 6th grade was key is that if you're going to go into STEM subjects, which again is a key growth area and will be, you need to have the right subjects both at the middle school and then in the high school, and you have to have that motivation early on. So I think all of these things are really very critical.
And STEAM is something, you know, we've been kind of focused on heavily for a while, and just how to more integrate that into younger students, into, you know, neighborhoods of color, into, you know, all the different, into poverty. How do we make sure that everybody gets access? But arts also does play a role, and so we're seeing a lot of conversations around STEAM education.
Mm-hmm.
And how has arts played a role in just your development in either your career or your pathway or life or education?
Well, actually, one of the things I still remember from the 3rd grade was studying a work of art. And I still, when I go to Paris, I stop in the Musée d'Orsay to see it in person. So teachers of art, that same class, the same teacher also had us building little models of homes. And I've often said, if I ever have an opportunity for another career, it will be architecture. So I think it goes back to that period as well. So again, having that opportunity was critical. Then I lost your question.
No, that was perfect. What is the piece of art?
My memory should.
Oh, no worries. We'll find
It'll
out.
probably pop up,
If
and
you
I don't
saw it,
have.
you would know
I
in
don't
just
have
a
my
second.
augmented reality on right now.
Yeah. As you reflect back,
I can tell you what it looks like. A couple of peasants, a woman and a man in a field, listening for the music that would occur apparently at sundown.
oh. All right, the art teachers in the room, we're going to be waiting for you to come up to us afterwards.
Otherwise, I'll look at my phone and get the answer.
When you reflect back on your career, are there any decisions that you did not make that, looking back, you wish you had?
I've been actually very lucky through the career. I mean, one thing you always need to do is be open to the change, realize the world is changing, and be willing to accept that. So going from the hotel into engineering school was one. Deciding originally I was going to go and work after getting my bachelor's degree, but a couple of engineers I was on an engineering co-op program, said I should at least apply to graduate school, applied to MIT, and ended up going there. So again, a change in plans, staying on to teach, then ultimately going into business. Each one of these changes are major, leaving one company, starting another company. Luckily, along the way, I'm sure there were a number that a little course correction perhaps would have allowed things to happen more rapidly, or wouldn't keep me up at night worrying about how do we meet the next payroll or whatever. But overall, it's take the chance, and it's worked out. And it's interesting because I often am invited to both Harvard Business School, Stanford Business School. They do case studies on Qualcomm, and they'll present a case study on the early days of Qualcomm leading up to one of these decision points. And then the students talk about it, et cetera, and then they poll the students, which decision would you make? They always take the conservative decision rather than the one we actually followed. So sometimes it's worth, you have to think it through, obviously, but it's worth moving ahead, taking that risk, taking advantage of the change, adapting, because things will continue to change. It won't work the way you originally expected, and keep running with it.
How do you think we adapt? I mean, the system we're in now for traditional, particularly K-12, is very, you're right or wrong, you A, B, C, D, F, like we skip over E for some unknown reason. But we're kind of not really focused on giving room for risk. Is that something we need to be reevaluating in how we approach education? And is that something that we might want to be building into the system?
there's no question about it, because again, everyone is going to have to make these decisions. Decisions are risky as they go forward, which direction. If they're in a job that they're not really happy with, that's not the right answer, then they take a risk in making a change in that job, etc. So yes, being able to encourage the kids. Now, there's been classes in pass-fail. We've been very involved with High Tech High charter school system, and there the kids work on projects and present the projects, and the grades are somewhat tied into that. By the way, you asked about the STEAM issue. There, and I'm sure in other schools and school districts, there are a lot of classes where you combine both the science and math and the art. And in fact, at Qualcomm, for many years, we had art pieces done that either illustrate a physics theorem or a math theorem that were done by the students. So that's another way to kind of tie those together. But finding ways that students can test something and maybe then decide, okay, I tried overloading, but I'm going to drop this course and stay with that one. That's important. Here in California now, we have the different levels of schools. And so we have community colleges. If you're not quite sure, you can go there and then have another year or two to make a decision which way to go ahead. So there are these possibilities. I'm afraid that in a lot of our public school systems, there's just too many constraints on allowing change. And so I think it's important to try to open up union contracts, whatever it takes, to allow a little bit more flexibility in doing that. I still remember one of the failures we had actually was we supported a program at San Diego State for, we being Qualcomm, for training math specialists that could go into the grade schools and take over part of middle schools, I think it must be, take over part of the period for math and teach the math, and allow that teacher to go and teach something else during that period. But the rules wouldn't allow that. And so that program just never got off the ground, really. So we just do need to build in more flexibility. And again, the world's changing, the way we educate's changing. We just have to move with it and benefit from it.
Yeah, change is hard in big systems, but we do need to find a way. What are some projects that you are both working on right now that you're really excited about?
Well, we've got lots of projects ongoing that are fascinating. This obviously is one of them. How do we improve the K-12 and K-16 programs with technology, with innovation, et cetera? No simple one answer by any means, but let's explore and see what might come out of it. So this is exciting. One of the projects we got involved with recently was the Central Library in San Diego. And should we support building a new library? We're involved with digital technology. I read all my books on my phone these days, read my newspapers on my phone. Why do you need a library? And so each time we went and visited another city, we'd stop in to the library, always full of people. And so people like that social aspect of it as well, and being able occasionally being able to talk about things. Most of them are on computers. A few are in the racks looking for interesting books, etc., magazines, whatever, but always full of people. And so we did decide to support that, and I think, as you all know, it's been very successful. So having a good central library and then good local libraries is a key aspect. Salk Institute was mentioned before. I think, again, we've been mostly focused myself, on communications, information theory, but want to learn more about biology because we all need better health over time, and understanding the basics, the theory is really critical. So I thought I'd be able to, if I got involved with Salk, be able to catch up a little bit on my biology background. Well, I did catch up a bit, but the field is moving so quickly, I kept falling further behind, but it's still worth making the effort.
Do you have any career or life advice that you find yourself often giving?
Well, luckily, often I'll get young people coming in to say, I'm interested in starting a company, or I have started a company. How do I get to be the next Qualcomm? And so we talk about it, and of course the question is, what aspects, what properties do I need, what principles? And the first one is indeed be open to change. Whatever product you think you've initially planned, it's going to take longer to get there, and it's going to take some course changes, some dynamic programming of your company. So be open to that. Secondly, you have to have very good people to work with, and so you want to have a very good environment for people to work in. If you have interesting work, that's clearly one of the aspects. If you have a very positive environment, another, and if they're working with other good people, then you've got it made. And so that was an area we always follow. Then you have to keep up the communication. And so when you're only a few people, you can walk into every lab and talk with people, or into every office, or in the elevator, as was mentioned. But when it grows, that gets harder and harder. And so you have to then find other means. Luckily, at Linkabit, one of our early projects was the early internet. And in fact, we were one of the first three we built one of the first three networks that was used to prove the internet algorithm worked back in 1977, which I wouldn't even remember, other than the Computer History Museum celebrated the 20th anniversary, 30th anniversary, 07, 30th anniversary of that, and when we realized, well, I guess that was special at the time. So email turns out to be very, very useful. Texting.
I use that occasionally.
Use it occasionally. Good, good. And so we learned that actually putting the initial program together, because we built a SatNet over to Europe, had companies in Europe, US, et cetera, that were leading. The only way to keep everybody tied together was through email. And so with a company as it grows, make sure that you have email, but make sure that the hierarchy is suppressed. That is, somebody has a good idea, make sure they kind of put it out there, not just to whomever they're working for, but more broadly. And so we can take a look and, hey, that's a good one. Maybe it deserves some resource support. And so you have to just keep working at these things. That communication remains very important. And one thing I always advise whenever I had a meeting in the past, but I still actually give talks at Qualcomm to different groups, I always say that you should continue to think as Qualcomm as a startup, but a startup with a very good cash flow. So if you have a good idea, let's take a hard look.
That would be awesome. Every startup in the room's like, cash flow. It's been amazing. I could talk to you for days asking you questions, but we wanted to open it up to the audience to chime in and ask any question that you have that you might be thinking about. The only request that I have is that you keep your question concise so we can get to as many folks as we possibly can. And we do have a mic runner here, so we're going to spend about the next 20 minutes opening it up to you all. And I'd like to say thank you, by the way. So that was absolutely good.
By the way, while everyone's thinking of a question, we have gone back to New Bedford, and from a lot of the items we've learned here, we've introduced computers in the New Bedford, initially the high school system, now the junior highs, and provided teacher education, et cetera. And actually, the first thing I had to do was make sure the buildings got wired for wireless, and that there was home availability. But that program is now going ahead very well also. So
that's fantastic.
That's been something we came from USD, learned about that, and have taken it back to New Bedford.
Those are big challenges: connectivity, access to devices, both at home and in school. Yeah, are
right,
definitely
that's the
big challenges. So I think, do we have a question?
First one's always the hardest.
I hope not. I'm Jessica Huntsberger, and I actually teach a lot of your employees' children in Carmel Valley, and I teach French. And I heard you say Musée d'Orsay, and I wanted to know what the importance of language has been in your trajectory, and not necessarily just your language skills, but I know you employ people from all over the world. So what is the most important kind of like climate
Well, as I say,
practice?
communication
Not bad.
is critical, and obviously language comes into that. Of course, we're all spoiled now because a lot of the internet, not all of it, is in English. A lot of texts are usually available in English. In order to get my PhD, and I think they're dropping some of these requirements now. I had French in high school, so French was okay, but I had to learn German, and I don't advise doing this to anybody else because they had a 6-week course. I took the 6-week course, I passed the exam, and then in 4 weeks I forgot everything I learned. So that is obviously not the right way. But of course now, again, with the availability of wireless and materials available, including translation services, which are slow to come, but they're getting better and better. In fact, ultimately, even real time, that you have that type of capability available. But there's also another interesting aspect of that. With Qualcomm, one of the areas we're always looking out for is how can we make the technology be more socially useful? So one of the programs we started had to do with helping fishermen in India. And we provided phones for them. And we got to work with an operator there that would help provide some support and some applications. And they all had to be data because most of them were illiterate. And they still found, however, that getting the data, weather information, but most importantly, which fish are biting where, and when I catch those fish, which port should I go to, and which market is paying the most for that catch. And so they could read some of that information. But as a result, many of them decided they could get even more use if they became literate and they began to use the devices to gain some literacy. So these things happen.
Wonderful.
So my job is obsolete, it sounds like. This is great.
Yeah,
Thank you.
Thank you very much. It's interesting to think about what's going to be next, where we won't have to worry as much about translation in the typical sense, that eventually we'll be able to talk. I think there's a Star Trek episode with that somewhere.
Right.
I'm showing my nerdiness here. Question in the back?
You may have to repeat. I don't know.
Hi, I'm Christine. You took a ton of risks all the way throughout your life. And I heard you say at one point your wife was employed, so it was okay. And I get that. In your childhood, what as a child made you that kind of risk taker? Because we're not all built that way.
That's a good question. I'm not sure if I can put my finger on anything other than, again, I remember essentially the end of the Depression, just a year or two, couldn't afford a bicycle, etc. And then World War II occurring and trying to make do with very limited resources. And I was always interested in devices and how do you build things. And at that time, milk came in bottles with caps and a little wire wrapped around them that I could use to make electrical connections with batteries and bulbs. But
How old were you when you were doing that?
Oh, probably sub-teen.
Yeah. I wasn't.
7, 8, 9, right. So that was always fun. But then I became very interested in photography, and so they had very simple box cameras, and they had war surplus film that became available and chemicals. And so I decided, well, there was a coal bin. We weren't using coal in the house that we were renting, and the lower floor of the house we were renting. And so I built a darkroom in there and began to learn something. And then a man who had set up a photo business in his home came and asked whether I would develop and print pictures for him. Now, I was still just learning really. But I think that was one of the first very risky undertakings as well as entrepreneur.
So I'm guessing you said
Entrepreneurial.
yes before you were quite ready to scale up the business?
Yeah. So I learned a bit, and I'm afraid the customers probably learned a little bit along with me. The other problem was world surplus chemicals and paper couldn't always be relied on. But in any case, after a learning experience, it did turn out to be successful. So that was encouraging. So each one of these risks that you then build one upon the other, but you never get away really. You're taking a risk, you worry about it. With Qualcomm, I remember we often, every summer would have a picnic, invite the families, start out being able to do it in our backyard, but over time it grew to require the whole athletic field at UCSD. And I remember one day just driving up and looking down, it was about to go down into the field, and seeing it full of all of these people and children. And of course, then it hits you that you have a major responsibility that you've undertaken. So that's always an issue. At Linkabit, I often remember that you have a successful project, you build up staff so you can get that project done underway. And then the question always comes along, when that project's done, what do you do with all these people? And so you're always having to think, okay, what's the next and the next? And you take a few chances. You had asked earlier, how do you know they're going to succeed? You never know, of course, they're going to succeed. You begin to use as much information and background as you have, but then also you've got your intuition. And which ones might there be a reasonable market for if you're successful? How long might it take to get there, et cetera? And okay, this one and this one will take a risk on. And so you kind of feel your way, but you always have to be prepared again for the fact you're taking a risk, but you may have to make some changes to make it work.
How would you encourage your team at Qualcomm or any of the other organizations to take risks?
The main thing is never, ever shoot the messenger. The main thing, again, is you want people, if there's a problem anywhere, to bring it to you or bring it to whomever, but bring it to you and say, we've got this problem. And then your response, of course, is, okay, how do we solve this together? And so you're in it together. How can you make it work? If it's this direction not quite right, let's move over and find another one. The worst thing that can happen, two worst things in business that can happen. One is there's a problem and people don't bring it to the proper person as you in time. And therefore, it gets worse and worse. And by the time you get to it, you've got a really bad problem. So if you can avoid that, that's important. The second important thing is never lose a good employee. So you want to make sure that you're keeping people, a good environment, keep them happy, and interesting work to do, and listen and listen and listen.
Right over here.
Howdy, Michael Goodbody. I was fortunate one time to hear a high school student ask your son, Dr. Paul Jacobs, like what was a piece of technology that scared him? So I'd like to actually flip that around. Is there a piece of technology that you're really excited about that's in the near future?
And if we don't know about it, that's even better.
Well, we've talked about different career paths that people can go into. So health is obviously going to continue to be a major one. And the health industry is very slowly changing over to making use of technology. You've heard about the artificial intelligence, deep learning issues. Somebody mentioned getting into, I guess it was up on one of the graphs, getting into radiology. Well, already perhaps the deep learning devices are getting better than most radiologists at spotting issues. So some of these may be coming to an end, or Eric Topol mentioned, I think, on 60 Minutes this weekend, that gives the doctor more time to adjust. But in any case, the technology is coming, but what do you need if you're thinking of developing new products everybody carrying, that's where I keep my cell phone, everybody carrying a cell phone around with them. The cell phones have all kinds of sensors on them now. They're going to be able to detect more and more about your environment with privacy controls, where you are when you report back something about that environment. Privacy obviously very critical. And then being able to put together information about what's happening, is there a disease forming, is that going to move? The interesting thing about these technologies and the devices you need all kinds of different backgrounds, a lot more physics, for example, et cetera. For biological devices, much more basic biology. So the broad engineering, broad education with some deep education is important. But these things are going to continue to move ahead and change. And it's hard to predict which is going to be most important, but it's going to be something we're not really foreseeing right this instant. It's just because of that change. If I had, again, which ones I'm most excited about, artificial intelligence is making a lot of progress. As you know, there's a lot of concern in the world, quite rightfully, about between robotics, artificial intelligence, are there going to be jobs for us in the future? Well, clearly the jobs are going to change. I think, though, rather than thinking of a glass half full, nope, half empty, think about it as a glass half full. Namely, what that means is productivity is going to increase rapidly. It takes a while to learn to use these different technologies, to get the students familiar and then out working with them. It's usually the youngest, the ones who have the most recent education that then apply them. But it will have a major impact on productivity. So then our challenge is going to be, how do we distribute the results of that productivity, the services that are being able to be produced at lower cost, the different hardware, software devices and apps, how do we make sure people have access to those? And so the whole issue of economics is going to be changing very rapidly as we go ahead because of this. That gets you, of course, into politics. How do you get politicians worrying about these issues? So there's a whole range of things that change is introducing that we see maybe 5 years ahead. Beyond that, it's really hard, but that we know is going to be available. And if we treat it properly, is going to allow much more equality, I think, in our civilizations, if we, again, approach it properly.
I think that we often find different leading indicators, and technology right now seems to be pulling healthcare and pulling economics and pulling so much of that forward. It's just interesting to what you're saying. So we have a question right there.
Hi, I'm Shannon, and recently someone from my district, and I regret not knowing who, tweeted that if you don't have a mentor under the age of 35, you're missing out. Is there anyone like that for you currently?
Did you say a mentor under the age
Under
of 35?
the age of 35.
Okay, I was just clarifying.
Well, I mentioned earlier that my earliest mentors, in a sense, was my math teacher and my chemistry teacher, and both were, in some sense, discriminated against when they chose careers. One wanted to be a doctor, and one had difficulties getting into the proper college because of racial backgrounds. But they were wonderful for me. And so whenever I had an issue or problem, I would often go and talk with them. We've been lucky to be in a position to go back and set up a set of scholarships back in New Bedford and name them for those two teachers. Later, going to college, again, there's always one or two professors that really make an impact, have an impact. In my case, one of them was not younger, he was a bit older, but taught electromagnetic theory And he was the professor who called me to invite me to come out here to teach at UCSD. But he taught electromagnetic theory so well that we talked briefly about this satellite communication for trucks. Well, for satellite communication for trucks, you need an antenna that can receive a signal from a satellite where that signal is designed for huge antennas as opposed to little bitty antennas that you can fit on a truck. And I remembered enough about that EM theory, electromagnetic theory, to be able to design that antenna. And so, again, very useful. And finally, when I went to MIT, I was thinking of majoring in electromagnetic theory and antennas because I'd been so excited about them as an undergraduate. And I arrived at MIT in 1956, the exact same year that Claude Shannon, who again was a little older at the time, but when he was very young, had invented information theory while at Bell Laboratories at the beginning of World War II, really, actually thinking about cryptography, but then getting into what is information if we have to encrypt it, how do I measure that, how do I communicate? So whole theory of information that, by the way, has now entered biology and entered quantum physics. I mean, it's everywhere at this point. That got me quite interested, and I ended up in information theory. So you're never quite sure who or what, again, might strike you. Just mention an idea that really gets you excited and cause, again, a swerve in the direction that you're taking.
Do you have time to be a mentor today?
I do that quite a bit. As I say, a lot of young people come to me and want to start the next Qualcomm, and I try to help them and point ways of doing that, et cetera.
Is that the email subject line? Want to start next Qualcomm, ... and then
That works.
that works. We have time for one more question. Yes.
So I'm just curious, with all the work that you've done in schools, I'm curious of what you think that our classroom should look like, because obviously at Qualcomm you've created a wonderful workplace. People come all over the world to work for your company. So obviously you have found something that works in the workplace. And I'm just curious about how you would like to see that translated to our classrooms. Like, what can we do and how can we make that look better?
Well, I think the flexible classroom space, tables, a few people working on projects at a given time, which is now, I think, a lot of classrooms are being transformed, is indeed a very good path forward. I remember going into one class which had just had computers for a while, but it was broken up that way. And we were, it was American history, but also civics. And I was pleased that they were still teaching civics. And so the class at the time we went in there, they were looking, each individual group, this was during the 2016 presidential primary campaign, they were each doing research on earlier periods of campaigning and how the campaigning was done at those earlier periods. And so the groups were talking among themselves, small groups. And then the teacher said, okay, let's get together and compare notes. And so they began then to discuss how things had been in the past versus how they were in 2016, which I hated to ever leave the classroom. I mean, it was fascinating. And so that flexibility, I think, is a particularly important one. And combining that with ways that the teacher can track the information that each of the students individually, where they stand, et cetera. And so I'm hoping we move away from testing frequently to being able, again, with digital textbooks and URLs that you go to, et cetera, that you're able to get information back about each of the students, how they're doing, where they're weaker, where they're stronger, and then rather than have a test that tells you what happened, just tracking the progress they're making, be able to then redirect your attention to the students. Qualcomm in fact, I got interested in this whole area as a result of something Qualcomm had done. In the year 2000, President Clinton was very interested in the issue of the digital divide, which, although much less of a problem, is still a problem, clearly, around the country, around the world. But I went on a trip with him, and we went to, among other places, one small town in North Carolina, and we brought, at that time, a prototype of a high data rate wireless communication system for accessing the internet, set it up at a small company to be able to demonstrate to the owner of the company and the employees what having access to the internet at high data rates, what a difference that could make. You talk to your customers, your suppliers, get information if there's problems, be able to really in any case, that worked out well. In fact, President Clinton got so excited, it took a while to tear him away from the wireless terminal into a round table. And the round table, the governor at the time was Governor Hunt. And so one of his challenges to me was, okay, you came here with a prototype system. What will you do when these systems go commercial? And so a few years later, we went back to 4 high schools in North Carolina and gave classes in each of the high schools, what were then smartphones, nowhere near as smart as we have these days, and provided some help for the teachers. We had a couple of universities. USD was not involved at the time, but others, with how do we prepare material, how do you prepare the teachers, how do you, in fact, orient even the students for this change. 9 months later, I went back to see how things were going, and one teacher said, well, I have 2 classes, one of my classes with phones, one of my classes without phones. The class with the phones, 100% passed their Algebra 1. Class without phones, only 2/3 passed. And, you know, with an educational experiment ongoing, everybody gets a little excited to expect some improvement, but this was rather marked. And so began to ask why. And again, the answer was this issue of 24/7 and peer-to-peer. Student would say, well, I'd go home, try to solve a homework problem, couldn't solve it, parents couldn't help. Normally, I'd wait till the next day to see the teacher. And now I simply went online and got information from the other students. And then some of the students said, yes, and if I have a really good idea, I video it with my phone and send that around. So again, it was a lot of peer-to-peer and 24/7 type. When we went back a few years later, I was speaking to another teacher, and he said, and this was still before these things were really moving ahead rapidly, he said that now I turn 2/3 of my classroom time over to the students to present different work that they've done at home and brought in. And I use that time to talk with the students having more problems, and then 1/3 I'll talk more generally to the class. So already having a rather interesting impact.
That's fantastic.
Right.
Yeah.
And then that led, by the way, over time to the FCC becoming interested in how they support this, provide low-cost wireless, so making that more generally available. And then the Congress had set up, in President Bush's time, Digital Promise, but it had never gotten off the ground. And then in President Obama's time, it did begin to move. I joined the board for the first couple of years. And that also began to broaden and spread some of this. And of course, it's still growing and has a network of interested school districts going.
That's amazing. Would love to thank Dr. Dolly for all her work on helping make this possible, and all of you for coming today. And thank you, Dr. Irwin, for giving your time. We really, really appreciate it.
Thank you.
So, thank you.
Very good. Thank you all. Very good.
And I believe the happy hour is next. All right, we have one quick announcement.
We would love for you to join us at the Innovator Mix and Mingle right out here on the patio starting in a few minutes.
No worries. I hit it somewhere over there. Thank you very much. That was fantastic.